Hi, welcome to my new video on limit. So what is limit? Limit is the value a function takes as its independent variable approaches a certain value. So what does it mean? Say there is a function of x, fx. Here x is the independent variable and fx is the function of x or the dependent variable. If so, what is limit? If for x approaching a number, say approaching a value, say a, fx approaches say a value which can be equal to any letter, we can say it is b, then we can write limit x tends to a. This sign this sign is x tends to a for the function fx, and fx for x tending to a, fx is taking a value which is equal to b. I mean fx is approaching b. This is important. This is important. Let us take an example. Say fx equal to x is a function. Let us take a simple example. This is a equation of a straight line, as we know. So the straight line will look like this. Let us define the function. Let us fx equal to x for all the value except x is not equals to, say, at 2. Say at x equal to say when x is equals to 2, fx takes a value 4 at x equals to 2. So the plot will look like uh, one second. So the plot will look like this is 1, this is 2, this is 3, this is 4, this is x, this is fx. 1 2 3 4 5. So when the graph will look like this, see at x equal to 1, fx will take 1, at x equal to minus 1, fx will take minus 1. All the values will be same except at x equals to 2 there will be a discontinuity. Let us denote this discontinuity with this small circle. At x equals to 2, fx will take the value 2 3 4 4, and otherwise it will be same as this equation. So we can say here, when the limit x tends to 2, when x tends to 2 means x is approaching 2, the approaching value of x is the approaching value of x theoretically means it will never end approaching. It will never end approaching means the difference between 2 and the approaching x and the value x is taking by approaching 2, the values x is taking by approaching 2 will be infinitesimally small. So like from if x is approaching from this side, then the value will be 1.9, 1.99, 1.999, and so on and so on. So the limit here will be as x approaches to fx. Fx, we can see fx here is approaching 2 also, as x approaches 2 from both sides of 2, from the both sides of x equals to 2, fx approaches the same value which is here. Fx is approaching in this way when x is greater than 2, when x is approaching 2 in from the 2 greater than 2 side, and when x is approaching 2 from less than 2 side, the fx also approaches 2. So as x approaches 2, we find fx also approaches 2 from both the sides. So when x approaches 2 from left hand side of 2, when x approaches 2 from left hand side of 2, the limit is written as limit x tends to 2 but from the left hand side, that is from the negative side. And when x approaches 2 from the right hand side, it is shown as limit x tends to 2 but from the positive side. This is the left hand limit, and this is right hand limit. In this case we can see that both the limit is equal. That means that, what does it mean? That limit x tends to 2 for fx is also 2, that is fx is approaching 2 when x is approaching 2 from the negative side is also 2, and limit x tends to 2 from the positive side for fx is also 2. So here left hand limit is equal to right hand limit. This is the condition for a limit to exist. Otherwise the limit will be considered as undefined. So here limit exists. Now we can show a different example where the LHL will not be equals to RHL and their limit will not exist. So limit basically means that x is the independent variable here we have considered is as x. X is approaching a certain value, and for that and due to that the function fx is approaching a certain value, and limit means it is never equals to, it is always approaching. Say we take a function to show this to show such problem. Let us take another function gx equals to 1 by x. Here we can see for x equals to 0, for x equals to 0, gx is undefined. Gx is undefined. We can see now that limit when x tends to 0, gx is undefined. When x tends to 0, gx is undefined. Okay. For any other value, gx takes defined values. When x is taking value of say 0.01, gx will take a value of 1 divided by 0.01, that is 100. When x is taking value of minus 0.01, gx will be minus 100. When gx is taking value positive 0.001, gx will be positive 1000. When gx will be taking value of negative 0.001, gx will take negative 1000, and so on. We can see that for all the positive side limit, that is when x is approaching 0 from the positive side, x is approaching, we can show it here. The graph will be like this. The graph will be like this. When x is approaching 0 from the positive side, it is approaching the next value will be 10,000, 1 lakh, and so on up to infinity, up to positive infinity. Gx will be approaching positive infinity. This is gx, this is x. But we can see from here, when x is approaching the same value 0 from this is approaching from the positive side. When x is approaching 0 from the negative side, this is 0 from the negative side, that is these values, the next will be minus 10,000, minus 1 lakh, up to negative infinity. Gx will be approaching negative infinity. So we can write from the concept we have just discussed, this concept, that limit x tends to 0 from the positive side, that is the right hand limit, for gx is not equals to limit, let me tell first the value is positive infinity, and for the left hand side limit x tends to 0 from left hand side, that is the left hand side left hand limit for gx will be negative infinity. So ultimately we can see that RHL, right hand limit, is not equals to left hand limit. So if we have to find the limit of x tends to 0 gx, where gx is 1 by x, the limit will be undefined. Write it neatly, undefined, because of the fact this. So I think the concept of limit is pretty much clear. If you have any questions or you want to see some more examples of limit, please write in the comment section. So